This is exercise 1.3. We have to prove that 3 plus 2 root 5 is an irrational. So let 3 plus 2 root 5 is rational. Then it can be written in the form P by Q, where P and Q belongs to integer and Q is not equal to 0. Yes, look here. We have to prove that it is irrational. But we have read that 3 plus 2 5 is rational, just opposite of irrational is rational. So we have read this. Now if it is irrational, then we can write in the form P by Q. Okay, you know, any rational number can be written in the form P by Q. So P by Q is equal to 3 plus 2 root 5. So 3, okay, transpose to this left hand side. So P by Q minus 3 now is equal to 2 root 5. 2 is also transposed to this left hand side. So 1 by 2 in the bracket P by Q minus 3 is equal to root 5. Okay, so here this is irrational, this is rational, this is rational, 3 is rational, 1 by 2 is rational. So this whole is rational. The left hand side is rational. So 1 by 2 in the bracket P by Q minus 3 is rational. But you know, root 5 is irrational. Root 5, this is irrational. So irrational can never be equal to irrational. So our assumption is wrong. Hence 3 plus 2 root 5 is irrational. This is proved. Okay. In the same way, other we can prove. One thing I must say that when the family of irrational number is very big, if you multiply any irrational number to irrational, it is irrational. If we divide irrational by rational, it is irrational. If we add rational to irrational, it is irrational. If we subtract rational from irrational, it is irrational. It is. So family of rational is, it is very big. It is. Okay. So this proves that 3 plus 2 root 5 is irrational. It is. Now let us prove that root 5 is irrational. Okay. So solution, let root 5 is rational. Okay, we have to prove that it is irrational, but let it be rational. Let root 5 is rational. Then it can be written in the form A by B, where A, B belongs to I and B is not equal to 0. So, okay. So A by B is equal to root 5. Now squaring both the sides. A by B is equal to root 5. Now squaring both the sides. Squaring both the sides, we get A square B square is equal to 5. That implies A square is equal to 5B square. Okay. Now here B square is a multiple of 5. Therefore A square is a multiple of 5 is okay. A is a multiple of 5. That implies A is a multiple of 5. Now let A is equal to 5C. Now squaring both the sides, that implies A square is equal to 5C. Okay. A square is equal to 25. If you square this one, you will get this. So that implies, okay, 5B square is equal to 25C square using this one, A1. Now this is using 1. We get that B square is equal to divide 25 by 5, you will get 5C square. So here B square is a multiple of 5. That implies B is a multiple of 5. So what do we find? We find that A and B both are the multiples of 5. Okay. Here you can let that. Here you can see here it is written that, okay, where right here where A and B has no any common factors. Okay. So now, anyways, so B both have the multiple of 5. So this, okay, this proves that this, okay, contradicts our assumption that A and B have no common factors. Okay. Therefore root 5 is irrational. It is proved.